Okay, hi guys. Today we're looking at transformations of square root functions. Yeah. The parent function is y equals to square root of x, and the basic shape is this because the square root of 0 is 0, so it starts at 0 0. That's its origin, and then gently curls up, going 1 1 4 4 2 9 3 and so on. Remember the mapping notation we learned when we first ever did transformations? X comma y is equals to bx 1 over bx comma plus h comma ay plus k, when y would be, in this case y would be a, then square root of b x minus h plus k, where h controls the horizontal shift, k controls the vertical shift, a controls the vertical stretch or compression and the reflection over the x-axis, b controls the horizontal stretch or compression and the reflection but over the y-axis. And this is how the graph y equals to square root of x looks like. So I'm going to try and see. Okay. Yeah, this other one. Label. I want to I want to I want to label this, and I don't know why it's not labeling. I guess not. Okay, we'll just move on. Basically 0 0, that's the origin. 4 2 1 1 4 2 9 3, and the graph goes on and on and on and on and on forever. You should get the clue over there. Let's do some transforming graphs. Y equals to the square root of x minus 4. Now, since the negative 4 is inside the square root, that's the h function, and it's the opposite. So we are graphing plus 4, which means the x-axis is shifting over by 4. So instead of 0 0, the origin will go to 4 0. And instead of 1 1, the origin will go to 5 1. Not the origin. The point will go to 5 1. Instead of 4 2, it's going to 8 2. And instead of 9 3, it's going to 12 3. And it goes on and on and on and on forever. Putting it into Desmos, y equals to the square root of x plus 4. We can x minus 4, not plus 4. Okay, we can see the blue is the transform function and the red is the original. We can see everything moves up by 4. This is 4 0, 5 1, 8 2, 12.3. It's supposed to be 13.3. Sorry, that was my bad. 13.3. I did not do a simple calculation right. . 13.3. Okay, next equation, y equals to negative square root of x plus 2. The two move up, and instead of going in this direction, it would go in this direction. It would be reflected over the x-axis. It will flip over the x-axis. So okay, 0 0 give us at x-axis nothing, it remains 0, and on the y-axis it will be negative 0 plus 2, which is 2, so 2 0, and then 1 1 would go negative 1 plus 2, 1. So that'll be negative y plus 2, in case you're wondering. 4 2 will give us negative 2 plus 2, 0, 4 0. 9 3 would give us negative 3 plus 2, negative 1. And bam, bam, bam. Look at it in Desmos. Y equals to negative square root of x plus 2. We can see it over here. It flips, and we can see at 1 1 nothing changed, but basically 2 0 1 1 4 0, and then 9 negative 1. Next one is y equals to 2 square root of x plus 1 minus 3. Okay, x plus 1. The plus 1 is inside the square root, so we are shifting the graph 1 to the left. And y, 2y minus 3. The graph is multiplying, so it's stretching. So the graph is getting taller and steeper, and it's going down by 3. So 0 0 would start at negative 1, negative 3. 1 1, that'll be 0. 0 negative 1. 4 2 would be 3. 1. And it will go like that forever. Let's put that on Desmos. Y equals to 2 square root x plus 1 minus 3. And we can see it here. It starts from 1 negative 3, 0 negative 1, 1 point. No, that's not what I wanted. Nope. What's the other one? 3 1, and so on and so forth. So it's important to remember, inside the square root the sign is reversed when thinking about horizontal shifts. Outside the root the signs means exactly what they look like. Positive moves up, negative moves down. The number multiplying the roots controls how stretched or compressed the graph looks vertically. If it is negative, it also flips the graph over the x-axis. So that's all for today. And if you want me to cover other radicals, inverse functions, or even transformation with absolute value or radical functions in more depth, drop a comment below. And check out our playlist of transformations over here. It has every single transformation details from the beginning, and it has some of this other function I talked about. But if you would like me to do this in more depth, please let me know in the comment section. And I just want to talk about my posts place. This is where I put out details of apps and whatnot. So all you have to do actually is just come to search up Damsy Tutors, or if you are following us, go straight to your subscription and then you press Damsy Tutors. You see it here, you go to posts and you can see every single details. And every Wednesday we usually drop weekly redos where you can try your chance for some solving. This week the video was late and we brought it out on Friday. Last week there was no video, and this showed us that I posted an update on our post saying that there won't be any video, and basically gives us weekly redos and updates about our post saying, oh, there is no video this week, or the video this week will be changed to Thursday at 5 p.m. and so on and so forth. So if you ever need, so make sure you're checking our post to see details. And like this, we're working on some slogans for Damsy Tutors. Go over there and vote for the one you want best, the one you like best. Weekly redos and so much more. Also, we have our playlist where I have taken the liberty to put in every single video I posted into different playlists for easier access. We have the videos where you can look at like redos, math acts, how to use like the log sign, cos button on your calculators, and so much more. The Desmos calculator, graphing calculator, is also a cool thing to have in your tool belt for solving maths. It can give you any single thing you want. You can even go sine 70 and it will graph that for you. Oh no, it's not. It will solve that for you. I forgot how to use this for sine. Oh yeah, here we go. Sine 5. Oh, that was my bad. I didn't put. And to graph anything for you, you can just go in there and to graph it for you. Right now it's a straight line because, well, there's nothing. But if I go like sine 90, it's just a straight line. But any single thing you would like to graph, it will give it to you. And yeah, Desmos is a really cool thing to have in your graph, in your math folder. And if you know you're going to be going into calculus, having a scientific calculator or a graphing calculator will be really good, and to also help you straight into the uni. So that would be a good thing. Yeah, thank you so much for watching Damsy Tutors. I'll see you next time.